Hello students, my name is Abdullapur Ramreddy. I am graduated from IIT Patna. I have been associated with askIITians from past 3 years. So this session is dedicated to a new chapter in organic chemistry, that is alkyl and aryl halides. So what are these alkyl and aryl halides? How we can form them? How do we name them? How do we classify them? So all these particular things we'll discuss in this chapter. So let's start the journey of alkyl and aryl halides. So we are going to start the chapter, which is a new chapter from organic chemistry, that is Haloalkenes and Haloarenes. So haloalkanes are also known as alkyl halides. Haloarenes are also known as aryl halides. So you can call them in both the ways. So let's start the chapter. So first we will discuss alkyl halides or haloalkanes, and then after completion of this particular alkyl halides, I will move to aryl halides. So what are the topics we are going to cover in alkyl halides? So let's see one by one. So under alkyl halides, first I will introduce the chapter. So what is meant by alkyl halide and all that, and then I'll move to the nomenclature, that is I'll discuss the IUPAC nomenclature as well as the common names. Then we'll also do the classification of alkyl halides, in how many ways we can classify them, and next we'll move to methods of preparation. So what are the methods that we employ in order to prepare alkyl halides, and then we'll see the properties. So under properties, first we'll study the physical properties and then we'll study the chemical properties. So this is the order that we're going to follow, not only for this alkyl halides or aryl halides, but this applies for every chapter in organic chemistry, whether it is alcohols, ketones, aldehydes or carboxylic acids. So any chapter, so this is the order which you have to follow, because it makes things easy. So even if you go to any other chapter, let's say alcohols, so first you'll study the introduction, and then you'll study the nomenclature, naming, and then you'll study the methods of preparation and properties and uses, of course. So let's start. I'll introduce the chapter first. So the introduction. Alkyl halides or haloalkanes are the compounds. They are compounds in which halogen is bonded to an alkyl group. So we know that alkyl group is represented by R. It may be methyl group, ethyl group, or propyl group. So the halogen. So we know what are halogens. So fluorine, chlorine, bromine, and iodine. So these four are our halogens. So basically, so alkyl halide is a compound in which the halogen atom is attached to a alkyl group. So this X may be fluorine. So if it is fluorine, then it is alkyl fluoride. If it is chlorine, then it is alkyl chloride. If it is iodine, then it is alkyl iodide, etc. So what is the general formula for that? So how we can represent the alkyl halide in general formula? So Rx is the general formula, where R is our alkyl group and X is the halogen atom. So alkyl groups typically have this general formula, CnH2n plus 1. X is the halogen atom. So this is an alkane. So an alkyl halide will be formed if I remove this X, if I remove this H, and in place of H, if I put X. So basically it is a substitution. So where H is substituted by one or more halogens, right? It can be one halogen, it can be two halogens, etc. So alkyl halide is the one which is in which one hydrogen or one or more hydrogens are replaced by halogen atoms. So let's see the classification of alkyl halides then. So in how many ways we can classify? So this is the famous classification, that is primary, secondary and tertiary alkyl halides. So this classification is entirely based on the carbon atom to which the halogen attached, whether it is primary or secondary or tertiary. So if the carbon to which halogen is attached, so this is a bromine. So bromine is attached to this carbon. So this carbon is a primary carbon. So this is going to be a primary alkyl halide, and in this case this is secondary. So this is going to be so this is the primary position, and this is the secondary, and this is the tertiary, right? So tertiary butyl bromide. So this is carbon is tertiary, so it is going to be the tertiary alkyl halide. So primary and secondary and tertiary alkyl halide. So this is a simple classification that is entirely depends upon whether carbon is primary, secondary or tertiary. So then what is IUPAC nomenclature? So it's like official names. So each compound is given a particular name. So no two compounds are going to have the same name. So each compound is distinct. So its name is also distinct. So how do we name the alkyl halides in IUPAC nomenclature? So it is named as haloalkane. So haloalkane. So this alkane, it may be a methane, ethane, a propane, a butane, etc. This halogen, it may be a fluorine, chlorine, bromine and iodine. So it should be named as haloalkane. So yeah, we'll follow the basic nomenclature concepts here. So first we need to choose the longest carbon chain. So it is not necessary that we have to choose a chain which contains fluorine. It's not like that. So we have to choose a chain that is longest, the primary chain. So choose the longest carbon chain even if the halogen is not bonded to any of those carbons. So keep this thing in mind and use the lowest possible numbers per position. So if at all any substituents are present, so we have to number in such a way that the substituent should get the least numbering, right? So let's name this one. So here the first step is we have to choose the longest carbon chain. So undoubtedly this is going to be our longest chain, which is containing 1, 2, 3, 4 carbon atoms. So if the 4 carbon atoms, then it should be a butane, right? So meth is 1, eth is 2, prop is 3. So 4 is butane. So definitely it's going to be a butane, but prefix should be this substituent. So chlorine is our substituent, right? So chlorine is a substituent. Here the position of the substituent is important, right? Because chlorine present here is entirely different. They are going to be two different compounds, though they are isomers. So chlorine it should be chloro, right? It should be chlorobutane, but we need to give the importance to the numbering, right? So here you can go from left to right or you can go from right to left. You have both the ways. If you go from left to right, this carbon will be the second carbon. So left to right, the chlorine position is second. Right to left, the chlorine position is third, right? So use the lowest possible numbers per position. So we have to choose and we have to do the ordering in such a way that our substituent should get the least numbering. So left to right is our correct numbering. So this is 1, 2, 3, 4, right? So this is 2-chloro because chlorine is present at position 2. It should be 2-chlorobutane. So this is the correct name or the IUPAC name for this particular compound. So let's do one more example. So let's take this one. Yeah, I have given this example because many students, they may take that, they may give the importance to this halogen and they may take this chain, either including this chain. If you take this one or if you take this one, if you include this one, then it's going to be wrong. It's a completely misconception. We have to choose a chain which is containing the highest number of carbon. So undoubtedly this is our chain from here to here. So this is our chain. This is the longest chain, right? So 1, 2, 3, 4, 5, 6, 7. So there are 7 carbon atoms. So definitely it's going to be an heptane. 7 means heptane, right? And we have to give the numbering so that the substituent should get the least numbering. So if you go from left to right, 1, 2, 3, 4, or even if you go from right to left, that is 1, 2, 3, 4. So this carbon is in either ways, if you go from left to right or right to left, this is numbering 4. So it is the 4th position. This substituent is present at 4th carbon. But here thing is, before it was only chlorine, so we simply put chloro. But here there is alkyl group, that is ethyl along with the fluorine, right? So here also the numbering will be important, right? The numbering will be important, and this is ethyl fluoride. Okay, so the name will be, yeah, this is 1 and this is 2. So it is 2-fluoroethyl itself is the substituent name. So 2-fluoroethyl itself is the substituent name. 2-fluoroethyl is the substituent name, and this substituent is present at position 4. So it should be 4 dash, in the brackets you need to write 2-fluoroethyl and heptane. So it is 4-2-fluoroethyl heptane. So in order to distinguish this name from the overall name, we have put this branch or this substituent in the brackets. So we get to know that the 2-fluoroethyl is the one substituent that is present at 4th carbon of heptane chain. Okay. So this is the thing. So let's do more questions. So here the nomenclature is like that. You have to do more and more questions to get the practice. Yeah, this is other different question. So there's a twist in this problem. Let's see. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So it is containing 9 carbons. So it is definitely going to be a nonane. And you can see we have the first step is done. That is the choosing the longest chain. And the second step is what? Numbering. So numbering you can do from left to right or right to left. So if you do from left to right, let's say 1, 2, 3, 4, 5, 6, 7, 8 and 9. So I am doing from left to right. So I will do right to left. So if I do right to left, this is 1, this is 2, 3, 4, 5, 6, 7, 8 and 9, right. So if you see there is not only one substituent, there are 2 substituents. That is a twist. If one substituent there, say suppose if methyl is only there, then we would have taken definitely this from left to right, because the methyl is getting the lowest numbering. But here both there are 2 substituents. So how to see the numbering in this case? So here we will follow the lowest sum rule. We follow the lowest sum rule. So the lowest sum rule is the one in which the sum of the carbon positions where the substituent present should be the lowest value. Say it is 2 plus this is 6. So 2 plus 6, which is equals to 8 in this case from left to right. If I go from here, so this is 4 and this is 8. So 8 plus 4, that is 12. So the lowest sum is 8. So we need to go for this. So left to right is the correct one. So it is 2 methyl and 6 bromo, right. So it is 2 methyl and 6 bromo. This is the numbering, 6 bromo, and we have nonane. And the thing is the order in which we need to write. So you can ask like I need to should I write methyl first or should I write bromo first, or like which order we need to follow. So here give the complete priority to this alphabet only. Don't give the priority to 2, 6. So let 2 is first, 2 comes first. So 2 is less than 6. So I will write 2 first. No, that's not the way. Don't give the priority to the numbers, but give the priority to these alphabets as from alphabetical order. So B comes first in the alphabetical order. So it should be 6 bromo and 2 methyl. 6 bromo, 2 methyl. 6 bromo, 2 methyl nonane. So this is the answer for this. Okay. And if you see in this case, it is a cyclic compound. Cyclic. So before we have open chain compound, but it is cyclic. So give the numbering. So you need to give the numbering so that the substituent should get the least number. So that you will get if you give from 1 here and 3 here. 1 here and 3 here. So you can number. This is cyclohexane, and one is bromo, another is fluoro. Okay. So this is 1 and this is 3. So it is bromo should be, we have to write bromo first because B comes first and F comes later. It is 1 bromo, 3 fluoro, cyclohexane, but it is cis. Cis is something important here, because here both the groups, both the substituent are present only one side. So that's why it is cis. If they are present at opposite side, then it's going to be trans. So if I write like this, if I instead of this solid wedge, if I write like this, like if I write bromine like this, and if I write hydrogen like this, so that means bromine and fluorine are not the same side, so they are opposite side. So that's why it will become trans then. But since these two are present in the same side, so we have taken cis here. Okay. Now we'll see the systematic common names. So the IUPAC names, they are official names, but for some compounds we use the common names, but not for all, only for some compounds. So the alkyl group is a substituent on halide. So I have taken 3. So let's see the common names for these 3. So this is actually butyl, isobutyl group. This is, so you might know that isopropyl and isobutyl. So this is the isopropyl group, 3 carbons, and this is isobutyl group. This group is isobutyl group. Okay, so it is isobutyl bromide. If chlorine is there, then it is isobutyl chloride, like that. So it's a common name. We are not giving any numbering and all that. That we will do in IUPAC, but we don't do in common. So if you see, this is secondary butyl bromide, and this is tertiary. This carbon is tertiary, so it is tertiary butyl bromide. Okay, so we don't use IUPAC names for some compounds. We generally call with the common names, but these are useful only for small alkyl groups. Okay, so before examples we have taken, so they don't have common names because we cannot call them in a common manner as we are doing here. So IUPAC name is must for everybody, but every compound, but for common names only for some small alkyl groups. Okay, common names of halides. So this is CH2X2 with this methylene halide, and this is haloform. Okay, so if X is chlorine, then we call it chloroform. If X is, that is halogen is iodide, we call it iodoform. So CHCl3 is chloroform, CHI3 is iodoform. Okay, if it's CHBr3 will be bromoform. Okay, and next is CX4 is carbon tetrahalide. So if X is fluorine, that is carbon tetrafluoride, and X is chlorine, then it's carbon tetrachloride. So which is methylene chloride. For example, if I take X as chlorine, so it is methylene chloride, and it is chloroform, and it is carbon tetrachloride. These are the common names of some other halides. So now let's see the types of dihalides. Dihalides are those compounds in which we have 2 halogen atoms, the 2 similar halogen atoms. Okay, so here we have 2 different types. So first is the geminal dihalide. So geminal dihalide is the dihalide in which the 2 halogen atoms are present only on one carbon atom. So here I am taking this example. So this is 1 and this is 2. So I have 2 halogens, so that's why it is dihalide, and these 2 halogens are present on only one carbon. They are present on only one carbon. So that's why it is geminal. Geminal means like 2 things are present on only one at one center. Okay, so it is geminal dihalide. And what if they are present adjacent? That is, if one is present here and other is present in adjacent position. So that is known as vicinal dihalide. Okay, so in vicinal dihalide we have halogen atoms which are, one halogen atom is at this carbon, present at this carbon, and other halogen atom is present at the adjacent carbon. So this is the vicinal dihalide. So dihalides, there are only 2 types. Whether if they present on only one carbon, then it's going to be geminal. If it is present adjacent, then it's going to be vicinal. That's all. Okay. So let's see the polarity and reactivity. Polarity and reactivity. So polarity, that is the due to the presence of polar covalent bond. So this is a covalent bond which is polar because of the electronegative difference between the carbon and halogen, and this will get partial positive charge because halogen is more electronegative than carbon. So as a result, the chlorine will attract the bonded pair of electrons strongly towards its side. So that's why it will acquire a partial negative charge, and due to the temporary deficiency, it will get a partial negative charge. Remember, these are partial charges, they are not the real charges. They only indicate that there is some electron deficiency at this position, and at this position there is some electron deficiency, and at this position there is some electron rich. Okay. So if you see, since this is a electrophilic center because of the deficiency, so a nucleophile can come and can attack this carbon. So as a result, these alkyl halides are reactive because the carbon to which the halogen is attached is a deficient carbon, electron deficient carbon. So it is a polar, they are polar and they are also reactive. Okay. So the reactions we'll see in the next slides. So it's now we need to know that at least why they are reactive, okay, and what is the position at which the nucleophile can easily attack. So students, in this part we discussed about alkyl halides, that is how do we classify them and how do we name them by using IUPAC nomenclature. We also seen the types of alkyl and aryl halides, and we also discussed about the polarity and reactivity of alkyl and aryl halides. So what are the methods through which we can prepare these alkyl halides? So that I am going to discuss in my next part. So keep watching.